Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today, integration of exponential and logarithmic function. Let's start with the definition of integration. Let f be a continuous function if we can find another differentiable function g at every point in its domain such that g dash of x equals f of x, then g of x is called the inverse derivative of the function f or antiderivative. G of x is denoted by integration f of x dx. This means g of x equals integration f of x dx if and only if g dash x equals f of x. Now we have theorem 1. Integration x to the power n dx equals x to the power n plus 1 over n plus 1 plus c, where n doesn't equals negative 1 and c is a constant. Example, find number 1 integration x to the power 10 dx, number 2 integration x to the power 2 over 5 dx, number 3 integration 4th root of x to the power 3 dx, number 4 integration 1 over x to the power 6 dx. Now, what is the integration of x to the power 10 dx? Equals x to the power 10 plus 1, which equals 11, divided by 11. 11 is the power after adding 1 to it, plus the constant c. Number 2, integration of x to the power 2 over 5 dx equals x to the power 2 over 5 plus 1, which equals 7 over 5 divided 7 over 5 plus c. X to the power 7 over 5 over 7 over 5 equals 5 over 7x to the power 7 over 5 plus c. Number 3, integration of 4th root of x power 3 dx equals integration x to the power 3 over 4. We can change the form of the root, 4th root of x power 3 to the exponential form of x to the power 3 over 4. Now, what is the integration of x to the power 3 over 4 dx? Integration equals x to the power 3 over 4 plus 1, which equals 7 over 4, divided 7 over 4 plus c. Now, x to the power 7 over 4 divided 7 over 4 equals 4x to the power 7 over 4 over 7 plus c. And now we can change the exponential form to roots form. Then the integration equals 4 multiply the 4th root of x to the power 7 divided 7 plus constant c. Number 4, integration 1 over x to the power 6 dx equals integration x to the power negative 6 dx. Now, the integration of x to the power negative 6 equals x to the power negative 6 plus 1, which equals negative 5 divided negative 5 plus c. x to the power negative 5 over negative 5 equals negative 1 over 5 to the power 5x to the power 5 plus the constant c. To make this works easy, we have the following rules. Rule number 1, if a is a constant, then integration a times x to the power n dx equals a times x to the power n plus 1 divided n plus 1 plus c, where n doesn't equals negative 1 and c is a constant. Rule number 2, integration dx equals integration 1 dx equals integration x to the power 0 dx. Integration x to the power 0 dx equals x to the power 1 divided 1, which is x plus c, where c is a constant. Rule number 3, if a is a constant, then integration a dx equals integration a multiply x to the power 0 dx equals a times x power 1 over 1, which equals ax plus c, where c is a constant. Rule number 4, integration of f1 of x plus or minus f2 of x plus or minus f3 of x plus or minus f4 of x plus or minus up to fn of x dx. The integration equals integration the first function f1x dx plus or minus integration the second function f2x dx plus or minus integration the third function f3x dx up to integration fnx dx, which is the last term. Now, theorem 2. If a and b are two constants, then integration between two brackets ax plus b all to the power n dx. Now we have a bracket, the function inside the bracket of the first degree, polynomial function of first degree, or x to the power 1, and the bracket have a power n. Integration of the bracket ax plus b all power n dx equals ax plus b between two brackets to the power n plus 1 divided n plus 1 multiply coefficient of x, which equals a, plus the constant c, where n doesn't equal negative 1 and c is a constant. Example, find integration 2x minus 3 all to the power 6 dx. Number 2, find integration 11 minus 3x all to the power 4 dx. Number 1, integration between two brackets 2x minus 3 all to the power 6 dx. Now we have function inside the bracket. The function is polynomial function of first degree, or x to the power 1. Then the integration of this bracket equals 2x minus 3 all to the power 6 plus 1, which equals 7, divided by 7, the new power, multiply the coefficient of x, or the derivative of the function inside the bracket. Then the integration equals 2x minus 3 all to the power 7 all to the power 7 multiply 2 plus c equals 2x minus 3 between two brackets all to the power 7 divided by 14 plus constant c. Number 2, integration 11 minus 3x all to the power 4 dx. Now the function between the two brackets is a polynomial function of first degree, or x to the power 1. Then the integration equals 11 minus 3x all to the power 4 plus 1, which equals 5, divided by 5, multiply the derivative of the function between the two brackets, which equals negative 3, plus the constant c. Then the integration equals negative between two brackets x 11 minus 3x all to the power 5 divided by 15 plus constant c. Theorem number 3. Integration f of x all to the power n multiply f dash x dx equals. Now we have a function between two brackets and the bracket to the power n. Multiply the derivative of the function between the two brackets. F dash is the derivative of f of x. Then we have integration function f of x to the power n multiply the derivative of the function between the bracket f dash x, the integration with respect to the variable x. Then the integration equals the function f of x all to the power n plus 1 divided n plus 1 plus c, where n doesn't equals negative 1 and c is a constant. Now we move to the next example. Find number 1, integration between two brackets x power 2 minus 3x plus 5 all to the power negative 7 multiply between two brackets 2x minus 3 dx. Number 2, find integration between two brackets 3x power 2 minus 2x plus 1 all to the power 11 multiply between two bracket 3x minus 1 dx. Number 1, the function equals f of x equals x power 2 minus 3x plus 5. What is the derivative of this function? F dash equals derivative of x power 2 is 2x and the derivative of negative 3x is negative 3 and 5 is a constant function. The derivative of 5 equals 0. Then f dash equals 2x minus 3. Now integration x power 2 minus 3x plus 5 all to the power negative 7 multiply 2x minus 3. We can apply theorem 3. We have a function between two brackets to the power negative 7. The function is x power 2 minus 3x plus 5. The derivative of the function inside the bracket is 2x minus 3. Then we have integration f of x power n multiply f dash x dx. Then the integration equals the bracket x power 2 minus 3x plus 5 all power negative 7 plus 1, which equals negative 6 divided negative 6 plus the constant c. And we can write the integration as negative between two bracket x power 2 minus 3x plus 5 all to the power negative 6 over 6 plus c, or negative 1 over 6 multiply x power 2 minus 3x plus 5 all to the power negative 6 plus c. Number 2, the function f of x equals 3x power 2 minus 2x plus 1, and the derivative of this function f dash x equals derivative of 3x power 2, which equals 6x. The derivative of negative 2x is negative 2, and the derivative of 1 is 0 because 1 is a constant function. Now, integration of 3x power 2 minus 2x plus 1 all to the power 11 multiply 3x minus 1 dx. the derivative of the function between the bracket is 6x minus 2 or 2 times between two brackets 3x minus 1. Now we can multiply the numerator and denominator by 2. Then half integration 3x power 2 minus 2x plus 1 all to the power 11 multiply 2 times 3x minus 1 equals 6x minus 2. And now we have between two brackets 3x power 2 minus 2x plus 1 all to the power 11 is a function. The derivative of this function is 6x minus 2. Now we can apply theorem 3 and the integration equals half times between two brackets 3x power 2 minus 2x plus 1 all to the power 12 over 12 plus the constant c, and we can write the final result as 1 over 24 multiply between two brackets 3x power 2 minus 2x plus 1 all to the power 12 plus c. Now we can deduce the integration of trigonometric functions. Theorem: integration sine x dx equals negative cosine x plus c, where c is a constant. We know that the derivative of cosine x is negative sine x. Then the derivative of negative cosine x is sine x. Then integration sine x dx equals negative cosine x plus c. Number 2, integration cosine x dx equals sine x plus c, where c is a constant. And number 3, integration of sec power 2 x dx equals tan x plus c, where c is a constant. Now we have the following rules. If a is a constant and a doesn't equal 0, then number 1, integration sine ax dx equals, we know that integration sine equals negative cosine. Integration sine ax equals negative 1 over a cosine ax plus c, where c is a constant. Number 2, what is the integration of cosine ax dx? Integration of cosine equals sine, then integration cosine ax dx equals 1 over a sine ax plus c, where c is a constant. And number 3, integration sec power 2 ax dx equals 1 over a. A is the coefficient of the angle or the derivative of the angle. 1 over a tan ax. Tan ax is the integration of sec power 2 ax plus the constant c. And if we have sine complex angle like ax plus b, then the integration of sine ax plus b dx equals negative 1 over a, where a is the derivative of the angle, multiply cosine ax plus b plus the constant c. Number 2, integration cosine ax plus b dx equals 1 over a multiply sine ax plus b plus c. Number 3, integration sec power 2 ax dx equals 1 over a tan ax plus b plus the constant c. Now, what is the integration of the exponential function. We have rule number 1. If k is a real number where k doesn't equal 0, then integration e power x dx equals e power x plus c, where c is a constant. And the integration of e power kx dx equals 1 over k multiply e power kx plus c, and integration of e to the power kx plus a dx equals 1 over k multiply e to the power kx plus a plus the constant c. We know that the derivative of e power x is e power x, and the derivative of e power f of x is e power f of x multiply the derivative of the power. Now let us to move to the next example. Find integration of e power 4x dx. Integration of e power 4x equals e power 4x divided 4, or 1 over 4 times e power 4x plus the constant c. Now we move to the next example. Integration. Find the integration e to the power 7 minus 4x dx. The integration of e power 7 minus 4x equals e power 7 minus 4x multiply the derivative of the power, or multiply negative 4, then the integration equals negative 1 over 4 e to the power 7 minus 4x plus c. Another example. Find integration e to the power x plus e to the power negative x all divided by 2 dx. We can write this function as integration e power x over 2 plus e power negative x over 2 dx. And we can find the integration of each term, like integration half e power x dx plus integration half e to the power negative x dx. Now, what is the integration of half e to the power x? The integration equals half e to the power x plus. What is the integration of half e to the power negative x? Half multiply 1 over the coefficient of x multiply e to the power negative x plus the constant c. Then we get the integration equals half e power x minus half multiply e power negative x plus the constant c. Dear students, we note that rule number 2, if f of x is a differentiable function, then integration e to the power f of x multiply f dash x dx equals e to the power f of x plus c. We have function e to the power function, and the integration of e to the power f of x multiply f dash x, the derivative of the function in the power. Then the integration equals e to the power f of x plus constant c. Example. Find the integration 3x to the power 2 multiply e to the power x power 3 plus 1 dx. The function f of x equal x power 3 plus 1, f dash x equal 3x to the power 2. Then we have 3x power 2, which is the derivative of the power, multiply e to the power x power 3 plus 1 dx. Then the integration equals e to the power x power 3 plus 1 plus the constant c. Another example, find integration of sine x multiply e to the power cosine x dx. Now, what is the power? The power is cosine x. Then f of x equal cosine x, and the derivative of the power is f dash x equals negative sine x. Now, the integration of sine x multiply e cosine x e to the power cosine x dx, we can write this integration as negative integration negative sine x e to the power cosine x dx. Then the integration equals negative e to the power cosine x plus the constant c. And by this example, we come to the end of our lesson today, and till we meet again, it's goodbye.